Hello students, let us begin with the quiz. So today we are going to have quiz on the transistors.
Welcome to the on quiz, which we are conducting on the topics of semiconductor and the resistors. So in last session we have seen the demo of the conduction of quiz. Today let us have this live quiz, which will be useful as the preparation of your internals if it is conducted in online mode, or it will be useful for any competitive examination. So let us begin with our first question. So let me clear you. You have to read the question. We will give the timer, and in live session you have to put your answer while I'm giving you the time. So in the same time you have to upload the answer, and no one should copy and paste the answer, right? Why we are conducting this quiz? So that you should think about the answers, you should think about the topics. So I hope no one will just copy paste of the answers, but you will apply your own mind. So this first question is, a semiconductor is formed by dash dash bonds. The first option is covalent, second is electrovalent, coordinate, or none of the above. So your time starts now. While you just write your roll number, you can copy the roll number, and then you can write the answer or answer number. Like if you want to go for covalent, you should write 1. If you want to go for electrovalent, you should go for 2. So now 6, 7, 8, 9, 10. The time is up. We'll go to next question. The answer is covalent.
Is a semiconductor has dash temperature coefficient of resistance. Either it is positive, negative, or none of them, or 0. Think about it. So the hint here is the semiconductors, if they get heat, they release the electrons. So your timer starts now. 3, 4, 5, 9 and 10. The answer is negative. Semiconductors are negative temperature coefficient of resistance. The most commonly used semiconductor is germanium, silicon, carbon and sulfur. So you have to choose the semiconductor, because how we choose which one is most commonly used? Based on the availability. The semiconductor which is easily available, abundantly available, and if it is easily available, its cost reduces. So we go for the one which is widely available. So what is your answer for this? So your time ends now. The answer is silicon. Silicon is most commonly used semiconductor. Most of the devices are made by using silicon as a material. Those who are typing only number, I can see there, they should type the answers. Only putting number will not give you the attendance. This section is for, will give you 2 hours attendance, but you have to answer all the questions in given time slot only. So be careful. CRs, or if someone is, any one of you can put message in your unofficial group and ask everyone to join and participate in the quiz, and they can answer. So they have to answer in the given slot only. All the answers will be verified, and based on that only you will get 2 hours attendance. So let us move to next question. Next question is, a semiconductor has generally dash dash valence electron. How many valence electrons? Where do we have valence electrons? In the outermost shell of the atom. In the outermost shell of atom, there is a fixed number of electrons rotating. So what is that particular valence electron number for semiconductor? Either it is silicon or germanium. Both of them have same. So your timer starts now. You have, for this question we can give less time. So your time ends now. The answer is 4. 4 is the valence electron number for silicon as well as germanium. Let us move to next question. The next question is, the resistivity of pure germanium under standard conditions is about. So what is the resistivity? This is some table we have given in the beginnings introduction videos. While going for any objective examination, you have to prepare in such a way that you have to think which type of questions will appear. So value based questions appear normally in the examination. So I'm not expecting exact correct value at this stage, but you should think in this way while preparing for the objective type questions, that which type of questions may be asked while reading in the book. You have to remember the values also. So for this particular question, your time ends now. The answer is 60. Pure germanium resistivity is 60. So you have to remember this value. It is 60 ohm cent per centimeter. The next question, the resistivity of a pure silicon is about. It is 100, 6000, 3 into 10 to the power 5 or 6 into 10 to the power minus 8 ohm meter or centimeter. Your time starts now. In 10 seconds even you can watch it. You can refer some videos while giving answers. You can keep playing the video of the PN junction diodes. I hope everyone has practiced or seen the video at least once. The correct answer is 6000 ohm centimeter. That is the resistivity. Resistivity is the value, the amount. That amount is required, that amount which opposes the current. That is nothing but the resistivity. So this is the resistivity value. Now next, when a pure semiconductor is heated, the resistance, its resistance is, what happens with the resistance, whether it goes up, it goes down, it remains same or can't say. Your time starts now. So the hint is, again, when we give heat to the semiconductors, they release electrons, and electrons are nothing but the particles which are involved in the flow of current. So if your current is increasing, what should happen with the resistance, whether it should increase or decrease? The correct answer is it goes down. If your current is increasing, that means resistance is decreasing. Resistance is always opposite to the current. Right, the next question is, the strength of a semiconductor crystal comes from. Let me type the message for the students who are lately joining or just copy and pasting the answers. The strength of a semiconductor crystal comes from dash dash. The options are forces between nuclei, forces between protons, electron pair bonds, or none of the above. Your timer, let us start from 1. The strength of a semiconductor crystal, how they get the strength, how they are bonded with each other, what are the forces, which is the thing which keep these all electrons and other things attached with each other. So what is the answer? The answer is the forces between protons. It is the forces between protons which give the strength of a semiconductor crystal to the crystal. The next question is, when a pentavalent impurity is added to a semiconductor, it becomes. When we add impurities, we call that process as doping. And when we add this impurity to semiconductor, they become a specific type of semiconductors. Pentavalent, if it is added, then what happens with that semiconductor? Either it becomes insulator, intrinsic semiconductor, p-type or n-type. Your time starts now. This is very basic and important question. So for hint, pentavalent impurity have 5 valence electrons in the outermost shell, and semiconductor have 4 valence electrons. When these 5 are added to those 4, what happens? Whether we get excess number of electrons or holes. Are we adding electrons? If we are adding electrons, it will become negative type. If we are adding more holes, it will become positive type. So what is excess charge on electron? You have to think. And the answer is n-type semiconductor. When you are adding additional electrons to the system, so your negative type, it is becoming n-type, negative type. It is getting more negative charge because electrons have negative charge. Next, addition of pentavalent impurity to a semiconductor creates many dash dash. What does they create? Just now we have discussed the answer. Either they create free electrons, holes, valence electrons, or bound electrons. So your timer starts now. Valence electrons are fixed in the outermost shell. Bound electrons are bounded. Holes is the absence of electron, and free electrons are the electrons which are available for the conduction. So your time ends now. The correct answer is free electrons. When we add excess electrons, we get free electrons for the conduction. That's a very simple logic. Next question, a pentavalent impurity has dash dash valence electrons. So the name suggests penta. So you have to think what is the meaning of penta. The name penta comes from the valency numbers, how many number of electrons are present in the outermost shell of the atom. So I think it's easy to guess. Your time ends now, and the answer is 5. There are 5. Penta stands for 5, and there are 5 valence electrons. The next, in an n-type semiconductor is positively charged, negatively charged, electrically neutral, or none of the above. If this is part of our discussion, we are discussing for a while. In n-type semiconductor, N stands for which type of semiconductor? Positive, negative, neutral, or none? I think it's very easy to answer. So your time ends now. The answer is negatively charged particles. Okay, there I think there is some mistake in this clicking. So let me fix the answer. So we will change it. The answer should be negatively charged particles. Okay, fine. So our answer is negatively charged particles. Again, let us move to the next question. Next question is the trivalent impurity has dash dash valence electrons. 4, 5, 6, or 3. Your timer starts now. Trivalent, the name suggests tri. So I don't think there should be much problem in guessing the answer. So we'll just wait for everyone to post the answer. The answer is 3. There are tri means 3. There are 3 impurity valency. There are 3 valence electrons in trivalent. Next question is addition of trivalent impurity to a semiconductor creates many dash dash. So we have holes, electrons, or valence electrons, or bond electrons. Again, the same logic. Either he is taking electrons or giving electrons. Tri means 3. We are adding an atom who have 3 electrons in the outermost shell to a silicon or germanium. They have 4 valence electrons or shells in the outermost shell. So those 4 require another 4, but we are giving only 3. So what should happen? What will happen? Will be there excess of electrons? No, there will be vacancy of electrons. So the ones who are giving answer as holes, their answer is correct because they themselves require electrons. So they create the vacancy, they create the holes. Next question. A hole in a semiconductor is defined as a free electron, the incomplete part of an electron pair bond, a free proton, or a free neutron. So what happens? We get electron out from the atom due to some external force, and where there is absence of electron, we call that part as the hole. So what should be the correct answer? The correct answer should be the incomplete part of an electron pair bond. When there is electron, there is no hole. When electron jumps out of the particular place, there is incomplete part. It is the absence of electron. So those who are giving option 2, their answer is correct. Let us move to next question. The impurity level in an extrinsic semiconductor is about dash dash of pure semiconductor. So the options are 10 atoms, 1 atom, and 1 atom for 10 to the power 4 atoms, or 1 atom for 100. What is impurity level in extrinsic semiconductor? Extrinsic semiconductor, there are two types of semiconductor. Intrinsic, the one which is pure. When we get it from nature, we call it as intrinsic. Either it is silicon or germanium, we get it from the nature, and when they are naturally pure, there is no impurity added, there is no doping. Adding of impurity is called as doping. When there is no doping, they are considered as pure. So when they are pure, we add some doping and there will be some amount of doping. So the answer for this particular question is answer 2, 1 atom for 10 to the power 8 atoms. That means for 10 to the power 8 atoms of say silicon, we are adding 1 atom of say pentavalent or trivalent impurity. Impurity may be pentavalent or trivalent. So I think timers are coming in later stage. So let me fix it. So we are at the okay here. Right, this one is fine. So next question is, as the doping to a pure semiconductor increases, the bulk resistance of the semiconductor dash dash, it remains the same, or it increases, or it decreases, or none of the above. Your timer starts now. Now here, what we are talking about? We are talking about doping of a pure semiconductor. So when we are adding a doping, what should happen? Whether it's resistance, the bulk resistance of semiconductor should increase or decrease. What happens? Your time ends now. The answer is decreases. When we add doping to a pure semiconductor, increases. While doping is increasing, that means conduction is increasing. Conduction is increasing, that means resistance is decreasing. Next question, a hole and electron in close proximity would tend to, if electrons and holes are close, what will happen? They repel each other, attract each other, have no effect on each other, or none of the above. The hint is opposites attract. The nature's law is that opposites attract. Opposites always attract, and the same polarities, they repel each other. Your timer starts now for this question. I can give you 5 seconds are also enough. I can see there are answers. So if they are electron is negatively charged particle, holes are positively charged particles, so they surely attract each other. So the answer is attract each other. The next question is, in a semiconductor, current conduction is due to dash dash. Is it due to only holes or only free electrons, or holes and free electrons, or none of the above? So your time starts now. In a semiconductor, what happens? We have current. So what is the reason behind that current? Who formed the current? Either holes or free electrons, or both of them, or none of them. Your time ends now, and the answer is electrons and free holes. Free electrons and holes, both of them contribute in the flow of current. We have seen the virtual concept of hole current. When electrons move from left to right, that means they are jumping from one place to another place. So we feel that holes are moving in opposite direction. So the answer is both electron and hole. The next question is, the random motion of holes and free electrons due to Thermal agitation is called diffusion, pressure, ionization, none of the above. The timer starts now. Here the concept is talking about thermal movement of holes and free electrons. What may be the answer? Where diffusion takes place? Diffusion is related with the nature's law. Opposites attract. They form the potential difference. If you remember, pressure is some pressure applied, is some force. Ionization, none of them above. Your time ends now. The answer is diffusion. When there is formation of electrons and holes, there is natural tendency of them to diffuse themselves in the available area. If there is no external field, they try to go in uniform distribution. Everywhere their distribution will be same in uniform distribution. So the spreading of electrons and holes is called as diffusion. Next question. A forward bias PN junction diode has a resistance of the order of, either it is in ohms, kilo ohms, mega ohms, or none of the above. Your timer starts now. So if you have seen the lab sessions, we have seen the hardware lab session, and we have also seen the IIT software simulation. While taking these values, if you can remember what was the level of resistance in forward bias. Forward bias means when it is on. In on condition, what happens? You have to guess the answer. So what should be the answer? So your timer ends now. The answer is ohms. The value is in terms of ohms. So let us move to next question. Next question is the battery connection required to forward bias a PN junction are positive terminal to P and negative terminal to N, then negative terminal to P and positive terminal to N, or negative terminal to P and negative terminal to N, or none of the above. So if you have seen the PN junction diode and our recent classes, it's very easy question to answer. When it becomes forward bias means on. Either we should connect P type to positive, that is P, or negative to negative type N. How shall we connect it? Your time ends now. The answer is positive connected to P type and negative connected to N type. You can remember it like P to P and N to N for making it forward bias. So what should happen for making it reverse bias? It should be opposite. So the barrier voltage at a PN junction for germanium is about, what is the barrier potential? Either it is 5 volt, 2 volt, 0, or around 3 volt. So we have discussed about the barrier voltage. The barrier potential is something which is created due to the movement of electrons and holes. Here we have some correction. These values we will write in terms of say point. So this is 0 point. This is also 0 point, and this one is also 0 point. So what is your answer? 0.5, 0.2, 0, or 0.3? For silicon it is 0.7. So now we are talking about germanium. What should be the answer? Yes, the answer is 0.3 volt, right? Next question is, in the depletion region of PN junction, there is a shortage of dash dash. In PN junction for depletion region, what are the shortages? Acceptor ions, holes and electrons, donor ions, or none of the above. Your time starts now. In depletion region that is created around the junction. What is junction? Junction is the line or border which separates P type and N type. So when it separates P type and N type, around that junction, electrons and holes, they get attracted towards each other due to nature's law of attraction. Then they become immobile ions. So what is the shortage there? The time ends now. The answer is holes and electrons. When it is a depletion region, they become like a wall and they become the ions, immobile ions. They stop the further movement of electrons and hole movement. You can watch it in the semiconductor part 1, 2 and p-n junctions. So there are no electrons and holes in the depletion region. Next question is, the reverse bias p-n junction has dash dash very narrow depletion region, almost no current, very low resistance or large current flow. So let your timer start from 1. Time starts now. Reverse bias, what happens whether it is on or off? In reverse bias it is off. When it is off, when it is on, there should not be any depletion region. The circuit will break the depletion region and start flowing. What happens when it is reverse bias? In reverse bias it is off. So what should happen with the depletion layer? It should be narrow, small or large, almost no current or very low resistance. The answer is no current. If it is off, there is no current. Let us move to next question. Next question is, a p-n junction acts as a dash dash control switch, bidirectional switch, unidirectional switch or none of the above. Your time starts now. p-n junction diode is, of course, it is used as a switch, but how can you control the switch? Can you decide when to on and when to off? As it is bidirectional switch. Bidirectional means both directional. Unidirectional switch, only in one direction or none of the above. Your time ends now and the answer is unidirectional switch. We get conduction only in one direction for the diode. When it is in forward bias, in that condition only it conducts. In reverse bias it does not conduct. So it is unidirectional switch. Let us move to next question. A reverse bias p-n junction has resistance of the order of ohm, kilo ohms, mega ohms or none of the above. So for a hint, forward bias resistance was in ohms. In forward bias, current is more, so resistance was less. In reverse bias, what should happen? In reverse bias, current is very less and the resistance is very high. So high resistance value, should it be in ohms, kilo ohms or mega ohms? Your time ends. The answer is mega ohms. It's above kilo ohms, maximum resistance to the current. Next question is, the leakage current across a p-n junction is due to dash dash. We get some amount of leakage current across the junction. Either it is due to minority carriers, majority carriers, junction capacitance or none. So directly we have rolled the answer here. Let us discuss the answer. Let us discuss the logic behind this. The leakage current means the current which we get due to the charges which are available in less amount, minority carriers. Why? Majority carriers, either they may go away from the junction or they may break the junction. But if they are going away from the junction in reverse bias, but still there are small minority carriers, they try to go in the opposite direction and they form the leakage current. So the answer is minority carriers. So timer is of no use here. Let us move to next question. When the temperature of an extrinsic semiconductor is increased, the pronounced effect is on junction capacitance, minority carriers, majority carriers or none of the above. Again, I think there is some problem in the timer. Let me fix it. So let me pause this one for a while. Okay, now this one is fixed. Again, let us go to next question. We are at 27. Okay, this one we have discussed. The next one is the leakage current. This one also we have discussed. Now next one, when the temperature of an extrinsic semiconductor is increased, the pronounced effect is on junction capacitance, minority carriers, majority carriers or none of the above. Temperature, when it increases, what happens? We get excess number of electrons and holes, but we already have doping for the majority carriers? So the answer is, already it was told, so let us move to next. The answer is minority carriers. Okay, the next question is, with forward bias to a PN junction, the width of depletion layer decreases, it increases, or remains the same, or none of the above. When it is forward bias, it is on. Just before some time we have discussed what happens with the depletion region. If there is a depletion region, we don't get on condition, we have to break it ultimately. So whether it will be increased or decreased, your time starts now. I think 5 seconds are enough for this question. Here, those who have not joined, I think I can see there are less students join now. Someone please text and call them again. We have still more, around 18 questions. Let them attempt half questions. If they attend, they will get at least 1 hour class attendance. Let the others join. Please call your friends also. So the answer is decreases. Depletion region should decrease so that we will get the conduction. Next, the leakage current in a PN junction is of the order. Leakage current is either it is in amperes, milliamperes, or kiloamperes, or microamperes. The leakage current is due to minority carriers. Minority carriers are not in much number. They are not more number. So what should be the value of leakage current? Whether it should be small or more? Your time ends now. The answer is microamperes. Very small amount of leakage current is present. In an intrinsic semiconductor, the number of free electrons are equal the number of holes, or greater than the number of holes, or less than the number of holes, or none. Your time starts now. It is about intrinsic semiconductor. So for a hint, intrinsic semiconductor is a pure semiconductor. When we add p-type or n-type material, then only they become positive or negative. Then only there will be more electrons or holes. What should happen when it is intrinsic or pure semiconductor? Your time ends now. So the answer is equal the number of holes to the electrons. Both are same. When we add impurity, then only the number will change. But till then, the number of holes and electrons are same. So let us move to next question. Next question is, at room temperature, an intrinsic semiconductor has many holes only, a few free electrons and holes, many free electrons and holes, or no holes or free electrons. So your time starts now. 2, 3, 4, 5. Again, intrinsic semiconductor is the pure one. So for the pure one, we get few free electrons and few free holes. Holes are not free or binded, they depend on the movement of electrons actually. Hole current is a virtual concept we have discussed in previous sessions. Next question is, at absolute temperature, an intrinsic semiconductor has dash dash. So what happens when the temperature is absolute? A few free electrons, many holes, many free electrons, no holes, or free electrons. Your time starts now. It is intrinsic semiconductor, and when temperature changes the resistance. We have discussed in the previous questions also, but this time we have intrinsic semiconductor, the pure one. Normally where number of electrons and holes are same. So what will be the effect of the absolute temperature? Your time ends now. The answer is no holes or free electrons. The next question is, at room temperature, an intrinsic silicon crystal acts approximately as dash dash. So how they approximately works? As a battery, or a conductor, or an insulator, or a piece of copper wire, like again conductor. So your time starts now. 2, 3, 4. In room temperature, how an intrinsic pure semiconductor will act? Either it will behave as Conductor, battery. Can we get battery operation from silicon or germanium? Can we call it a conductor if it does not conduct? Your time ends now. The answer is insulator. Intrinsic semiconductor, there is no excess electrons, there is no movement of electrons, so no conduction, it is insulator. Next question, under normal conditions, a diode conducts current when it is dash. When diode conducts, either it is reverse bias, forward bias, if it is avalanched or saturated. Your time starts now. This one is very simple question. It's very simple to answer. Seven, 8, 9, 10. Your time ends now. The answer is forward bias. When it is forward bias, then only it conducts. Next question is, the term bias in electronics usually means. What is meaning of biasing? The value of AC voltage in the signal, or the condition of current through a PN junction, or the value of DC voltages for the device to operate properly, or the status of the diode. So let your time start from 1. So your time starts now. In bias means when we connect the values, the voltage value at the input or output side. So what should be the answer? The value of DC voltages for the device to operate properly, or the status of the diode. Your time ends now. The answer is the value of DC voltages. What should be the input voltage? How much minimum voltage to be given to make that particular device in on condition? So that is the correct answer. The next, which of the following statements is incorrect? The first statement is, the voltages in a circuit are usually measured with respect to the ground or earth connection. If a body develops an excess of electrons, it will have an overall positive charge. An EMF represents the energy introduced into a circuit by a battery or generator, or a conventional current is in the opposite direction to flow of electrons. So your time starts now. So let us have 15 seconds to read the statements. Voltages in a circuit are usually measured with respect to the ground or earth connection. Is it correct? If a body develops an excess of free electrons, it will have an overall positive charge. Is it correct? What is the charge on electrons? Your time ends now. And the answer is, if a body develops an excess of electrons, it will have overall negative charge, not positive, because electrons are negatively charged particles. Next question is, which of the following is a correct statement of Ohm's law? Ohm's law, I think there should not be doubt to anyone, but still there may be confusing statements in examination. So either it is I is equal to V by R, V is equal to I by R, or I is equal to R by V, R is equal to VI. So let me pause it. There is some one here, so I have to let's pause it for a second till then. So now let us continue. So let me maximize it. So I hope everyone has the answer. Your time starts and ends now. The answer is I is equal to V by R. So V is equal to IR is the correct statement for Ohm's law. Now I think you should take the notebook and pen and calculate the magnitude of the current I3 in the following circuit. In resistance 1 and resistor videos, we have given the procedure to calculate the resistance between series. Direct calculation, here you have to apply the formula. So your time starts now. Let us have 15-20 seconds for answering this question. Everyone solve it. Everyone should remember these formulas to calculate the resistances, the overall resistances, because while developing or designing a circuit, if you are going for a project using sensors, motherboard or any controller, then most of the time we need to decide the resistance values. What should be the resistance value? At that time, if they are in parallel, how to make equivalent resistance? We should be able to know. So once we know the resistance, we can calculate the current, equivalent current for these two. So your time ends. Now we have to calculate the voltage in V2. What should be the V2? We know the supply voltage, electric field, it is 21. V1 is 7. What should be the value of V2? We know the basic Ohm's law, how current and voltage get divided. So how voltage will divide it here? What should be the answer? So let your timer start now. Whenever you solve examples in examination, first step you have to do is note down the given data. Once you note down the given data, after that you note down all the formulas related to that particular topic or whatever you remember. If you miss something, you can correlate. You can think for a while and decide it. The answer is 14 volt for this question. Let us move to next question. Calculate the magnitude of power dissipated in R3 in the following circuit. Now, what is power? Power is product of voltage and current. Let your timer start now. Let us have around 15 to 20 seconds. The given values are current and resistance. Current is available, resistance is available. Can you calculate the voltage? If you have voltage and current, can you calculate the power? Yes, you can. So calculate it. I think that's enough time. Okay. So the answer is 45 watt. Watt is the unit of power. Now next question, calculate the effective resistance of the following combination. This is the most simple question we also seen in the last demo. What we do in the series, we sum them all. So you have 3, 4, 7, 8, 9, 10. Your time is up. The answer is 49 ohms. Next question. Calculate the effective resistance of the following combination. R1 is 12 ohms and R2 is 4 ohms. Both of them are in parallel. If they are in single line, that means they are in series. Now both of them are connected across each other. So this condition is parallel condition. Only two resistance. You can calculate it. Your time starts now. 3, 4, 5, 6, 7, 8, 9, 10. Okay, time is up. The answer is 3 ohms. So what we do? 12 to 4 by 12 plus 4 and we get the answer. Similarly here we have two resistances connected across the voltage inputs and outputs. So we have to calculate output voltage here. What should be the voltage across this output between R1 and R2? We know the resistances, we know the voltages supplied to R1 and R2. Now we have to calculate the voltage. If you have input voltage, input resistance, we can calculate the current. We can also calculate the voltage if we have the current and resistance. So your time starts now. Let us have 10 more seconds. I think few students are simply pasting the answers without giving a thought. These quizzes are meant for your benefit. You should be excited while doing quiz. You should keep searching the answers and the formulas. You should remember it, and you have to reproduce it when you are required. So the correct answer is 10 volt. Now again we have similar kind of question. So for this question, answer is 6 volt. You can note down the values and you can practice it. Let us move to next question. A sinusoidal signal has a period of 40 milliseconds. What is its frequency? So there are basic relations between time period and frequency. Your time starts now. Let us start now. Let us have 10 seconds. What is the relation between time period and frequency? You have to find out. So capital T is given. You have to find out the frequency. In 1 second, how many cycles we are getting? That is the frequency of the circuit. Okay, so answer is 25 hertz. The next question is again very simple. It may probably our last question of the practice. What circuit element is represented by the following circuit symbol? What is it? Either it is individual voltage source, or a battery with an output voltage, a voltmeter. So your timer starts from 1. Your time starts now. We have discussed the symbols. What is this symbol? What this symbol stands for? Either it is voltage source or something like this.